In this video, we're looking at one of the major categories of the new functions, and that is vitamin biosynthesis. So when we're looking at vitamins that are produced by the gut microbiome, we can see that gut microbes can produce vitamin A, the full spectrum of vitamin B, vitamin C, and vitamin K2. This is really important to look at within the gut microbiome because what it can show you is your own unique vitamin status according to your gut microbiome. So what's interesting about a lot of these different vitamins is that you'll have a group of bacteria that can produce them, and sometimes they can utilize them, and then you'll have another group of bacteria that can utilize them. Sometimes there's an overlap here, and sometimes there's not. So what we see is that our gut microbes are actually producing a lot of these vitamins for us, so the human host can actually utilize a lot of these vitamins. They're right at the site of absorption. So they're helping us out and helping to essentially supplement our diet if perhaps we're not getting enough foods with these vitamins in our diets. So our gut microbiome can help us in that way. But in other ways, they can be using these vitamins almost like prebiotics. So a lot of these different gut bacteria will need various vitamins in order to survive, but they may not be able to produce them, so they may not be self-sufficient. So in this case, sometimes there's competition with the human host in order to utilize some of these vitamins and stay alive. So if we take a look at the test, what we can see first, we're going to see just a general marker of vitamin biosynthesis. So this one you're able to see compared to a healthy population, where does your gut microbiome fall? Are you right in the middle? Are you a little on the higher end, a little on the lower end? Anything within healthy range is going to be pretty normal, pretty great. But then what we've done is we've created subfunctions with individual vitamins. So you're able to go look even closer and see, are there disparities with any particular vitamin? Another thing that's really important to understand about vitamin synthesis within the gut microbiome is that some of our pathogens will actually produce a lot of these vitamins. So Clostridium difficile and Helicobacter pylori actually produce a wide variety of vitamins in the gut. And so this just goes to show that even though some of these bacteria can be pathogens and they can be harmful to the human host, they also play an important role in the gut microbiome. And so this is why it's important to not just adopt a mentality of kill, kill, kill when trying to address pathogens. The goal is not to completely eradicate them because they do have other beneficial functions within the gut microbiome. Rather, the goal is to recondition the gut microbiome to keep some of those opportunistic pathogens under control. So for example, if we're looking at thiamine, thiamine can be produced by some lactobacillus species, some bifidobacterium species, Ruminococcus lactaris, also Clostridium difficile. So if you're looking at your test and you see, okay, we have Clostridium difficile that's overgrown, then we can look at, okay, what could be causing this thiamine production to be low? And again, these aren't levels in the stool, but what we're looking at is the pathways that can be measured within the gut microbiome. So we're looking at these genetic pathways and or enzymes that have been identified in the research. So if, for example, thiamine is low, you can go then look at your keystone species and see, is my lactobacillus or my bifidobacterium low? If they are, then you can see, okay, I need to increase some of these particular keystone species. I can feed them some of these dietary fibers. There are also some keystone species that need various vitamins. So Faecalibacterium prausnitzii, for example, needs thiamine but can't produce it. So if you notice that thiamine is low and you also notice that Faecalibacterium is low, then it might be necessary to supplement the diet with a little bit extra thiamine. Alternatively, if you have a result that's very high, this could mean that you are producing a ton of it, and then it's important to look at which bacteria can actually utilize those vitamins. So is if the human host is absorbing all that it can absorb and there's still a lot being produced, then this might also, again, point to keystone species that are insufficient. So, for example, pantothenic acid, if that one is really high, that one is often utilized by Lactobacillus, Bifidobacterium, Ruminococcus. So if you go look at your keystone species and you notice that these are low, then that might help explain why the pantothenic acid or the vitamin B5 is so much higher than a healthy population. So by looking at these individual markers, this will help you really understand your unique vitamin status according to your gut microbiome.